Welcome to today's Explainer. We're diving into a fascinating and honestly pretty unexpected architectural shift happening right now in artificial intelligence. We're building the most advanced technology in human history, right? But as we push the absolute boundaries of what AI can do, the architecture powering it is starting to look a lot less like some crazy sci-fi movie and, well, a lot more like a computer lab from 1969. Let's get right into it. So, why exactly is cutting edge AI returning to 1970s architecture? It's incredibly ironic when you think about it. The AI industry has spent the last few years obsessively building these hyper complex, massive systems. And yet, to make the next big leap forward into truly autonomous agentic AI, developers are actually ditching all that complexity. They're stripping things way down and adopting operating system principles from over 50 years ago. Part 1. The monolith problem, AI's Multics moment. For the past few years, the major trend has been to build massive, opaque black boxes. These gigantic, monolithic systems trying to do absolutely everything all at once. We can call this the Multics approach. That's named after an infamous operating system from the 1960s that got so bloated it basically collapsed under its own weight. And frankly, large language models today risk facing that exact same fate. But there's an alternative. It's the Unix, or small language model, modular approach. Instead of relying on one giant tangled brain, this approach uses simple, transparent, highly specialized tools that do just one thing exceptionally well, and they work together seamlessly. This whole shift perfectly echoes a core programming philosophy. Take this quote from Eric S. Raymond. "The only way to write complex software that won't fall on its face is to hold its global complexity down, to build it out of simple parts connected by well-defined interfaces." It's a hard lesson, right? Heavy, overly complex systems historically fail. The AI industry kind of forgot this at first and repeated that old Multics mistake, but now they are definitely remembering the beauty of the Unix philosophy. Part 2. Echoes of Unix. Text as the universal interface. So what is the secret weapon actually rescuing AI from its own bloat? Believe it or not, it's just plain text. This crucial point was captured beautifully by Doug McGlory, the actual inventor of the Unix pipe, way back in 1978. He said, "Write programs to handle text streams, because text streams are the universal interface." Text is literally the most primitive, generalized form of expression we have. It doesn't need any proprietary decoders or overly complicated frameworks. Both humans and machines can effortlessly read it, write it, and share it. It really serves as the ultimate, totally transparent bridge for AI. If we trace this whole architectural evolution, we see we started back in the 1970s with Unix, heavily relying on pipes and simple text streams. Then, zoom forward to the 2020s, and we took this massive detour into monolithic, black box LLMs. But look at where we are heading now as we approach agentic AI. We're returning right back to text-based, modular subagents. We are actively moving away from those massive centralized brains and towards small, independent processes that communicate simply by passing plain text back and forth. Part 3. Agentic AI, running on plain text. When we look at concrete, modern applications, take Claude Code, for example, we're seeing cutting-edge tools completely abandoning complex databases and those heavy proprietary APIs. When you want to teach this AI agent new skills, you aren't using some convoluted framework, you just use standard markdown files. System hooks? Those are written in basic JSON. Executions happen via simple shell scripts. There are absolutely no proprietary binaries hiding the magic. It is 100% transparent. Anyone can just open these files up, read exactly what the AI is instructed to do, and even track the changes using standard, everyday tools like Git. Think of a commercial airline pilot for a second. They have the entire flight procedure perfectly memorized, right? But for absolute safety and predictability, they still pull out and read the physical paper checklist out loud every single time. Modern AI agents actually operate the exact same way. The model has this vast, incredible amount of knowledge memorized, but to operate predictably, safely, and transparently in the real world, it needs to physically read visible text files. So here's exactly how that mechanical process works under the hood. When the agent receives a task, instead of querying some hidden, opaque database, it just uses standard command line tools. We're talking grep to search for patterns or glob to find files. It then simply reads the plain text output. It's essentially acting like an intelligent software pipe. The agent executes a tool, reads the text results, and passes it forward. This makes the AI's entire thought process completely visible and, more importantly, totally debuggable. Which brings us to this really profound realization from Vivek Haldar. He noted, an LLM is, in a profound sense, exactly the user Unix was designed for. Just think about that for a second. Unix was built for power users, people who could string together small text-based tools to do incredibly complex things. Well, an AI agent, which naturally processes and generates language, is basically the ultimate power user. It reads the manuals, it writes the scripts, and it orchestrates the tools, all entirely through text.
Part 4. Personalization, the end of opaque vectors.
Now, this text-based revolution isn't just changing how AI is built, it is completely changing how AI remembers you. For years, your digital profile, basically everything an AI knows about you, has been stored as what we call an opaque vector. It's this long string of math that is completely unreadable to you and me. It's totally locked to one specific company's model, and it creates these incredibly fragmented data silos. But the new paradigm, well, as we see in recent research like Align X4+, it uses text summaries. These are entirely human-readable, easily transferable across entirely different platforms, and most importantly, they are fully editable by you. So how exactly does an AI build this plain text profile? The Align Explore Plus pipeline breaks it down into 3 simple steps. First, it generates text summaries of your preferences based on your past interactions. Second, it validates those summaries against your actual behavior to make sure it's getting it right. And finally, it merges them into one holistic plain text profile. Instead of keeping a massive, unreadable black box database of every single click you've ever made, the AI just continuously refines a single, highly accurate text document all about what you like. And why does this matter to you? Well, the benefits are absolutely massive. With the text-based profile, your data finally achieves what's called cross-domain transfer. That means your shopping preferences can instantly inform a conversational AI. It also allows for zero-shot model transfer. Basically, a completely new AI model can instantly understand you just by reading your text file, no retraining required. It cleanly resolves multi-interest profiles without getting the AI all confused. And above all else, it is human editable. If the AI misunderstands you, you don't have to fight some mysterious algorithm. You just open up the text file, fix the typo, and you're good to go. This level of transparency is absolutely vital for accountability. As the tech pioneer Jaron Lanier points out, teach a bot to share the most essential sources, it's the only concretely defined solution. When AI uses text as its universal connective tissue, it is literally forced to show its work. If an AI agent makes a weird, off-the-wall decision, you can look at the exact text file it read to make that decision in the first place and just correct it. No more black boxes. Part 5. The Modular AI Future. The famous Unix concept that everything is a file has now evolved into AI architectures where files are all you need. So, the things that flow have definitely changed, but the foundation? It hasn't. Back in 1969, we were piping basic data commands through early Unix terminals. Today, we are piping intelligent AI reasoning, super complex autonomous tasks, and deep user personalization. The content itself is infinitely more advanced, but the beauty, the simplicity, and the sheer resilience of that plain text-based architecture, that remains completely unbroken. Which leaves us with this final thought. If the ultimate AI interface really is just plain text, and we are now handing over the keys for AI agents to independently read, write, and execute these files, what happens when machines start writing the very files and rules that our algorithmic society lives by? It's a fascinating, maybe slightly wild future, and it is all being built on plain text. Thank you so much for joining me for this explainer, and keep questioning the architecture around you.